Everyone, welcome to Stelly RS, my YouTube channel. Today we are going to talk about the mixture of experts. Now, before we go into the weeds, we just want to know three things. Mixture of experts is composed of three things: the input, which is what I've represented here, the getting network or the router, and also the experts. Those three things are the core components of the mixture of experts. But before we go into the weeds, let's talk about its origins. Mixture of experts, the idea started in the early 1900s, but it has been revived in 2017, even latest in 2024 by Google, by Microsoft, by NVIDIA, by Mixtrial, and I believe, which company is this? Yeah, those are the main ones that revived: Google, Mistral, Microsoft, and NVIDIA. NVIDIA started out in 2022, popularizing this model. Then we have Google in 2021 and Mistral in 2024. All right. So, like I said, it started in the 1900s, but it has been popularized recently. Basically, mix of experts falls under deep learning or under ensemble learning, a subfield, which is a subfield of machine learning where multiple models or learners work together to improve the final performance. All right, so we said you have got inputs, you have got experts, and the router or the getting network. Alrighty, and let's. The reason why this is popular is because it kind of uses the divide and conquer approach to machine learning. Instead of building one monolith model that try to compute everything, it assigns multiple experts to tackle the same problem. Then each and every expert is weighted to give the final result. Alrighty. So let's go into my Jupyter notebook and let's see how we can do that using the code. All right. So first of all, we need to use PyTorch. So I'm using PyTorch here, and I'm also using the neural network model NN, and also I'm using the function because I'm going to activate functions like the ReLU and the softmax for softmax to assign the weighting on all the experts. I have 6 experts here, right? And also, let's talk about my expert model here, right here. Remember, we have the input, the expert, and the router. That's the 3 components. All right, so let's talk about the expert network. So here I am using just a small 2-layer feed-forward neural network. My feature vector here is 10 features. I'm going to use 10 features, and there's a hidden layer which learns the intermediate patterns, and also I'll come up with a single prediction or a small output vector. On the getting network, this is the one that decides which one handles what. Basically, on the getting network, basically on the getting network, which is the manager, or some call it manager, some call it router. It takes the same input as the expect, then the output, and it outputs 1 weight per expect. So let's say if I have 6 expects, it kind of rounds off, it assigns them. Let's say I'm going to use softmax here. So what softmax does is going to weighs everything and sum it to 1. So if I have 6 expects in here, like here I got 6, what happens here is each and every expect is weighted, is given a point like 0.7, 0.1, 0.05, 0.3, whatever it is, right? Then or the totals of those probability distributions should equal to 1. But depending on the expects, each and every expect is given, let's say expect 1 is given higher consideration to the output than the others. All right, or we call it higher attention rather. All right, let's talk basically about the mixture of experts model. So the neural network here create a list of independent experts networks. Like I said, I have a 6 different network, and I'm also using self-get here because it is my getting network. And my batch size is 8, my input dimension is 10, hidden dimension is 32, output dimension is 1, my expects again are 6. All right. Let's see what else. But basically, this is how you set it up. And now each expect processes the same input, which is X, and gives you a list of 6 outputs, and it then puts them together in a single tensor. And so for each input, you will now have all expect predictions side by side. And eventually, our output is going to be weighted. Yeah, this is basically how it's used. It can be used in many other things. The main advantage of this concept is that it is scalable. Instead of having, it uses less computational power. Instead of having one model handling everything, it breaks it down to multiple aspects. Then it speeds up the process, then combines the result. So we have what we call a larger representational power. It also is efficient specialization, and also we have parallel computing, which is what we need because it saves time, it saves resources. All right. Another worth mentioning is the challenges that the router, because it handles all these aspects, there is what we reference as routing overhead and also load balancing issues. But basically, right now, looking at the industry trends, this is what is going on into the market. People seems to be moving close to the mix of experts. This was a quick demonstration. What I'll do next is I will come up with we'll do the code along for a project like this. Then we'll explain everything in detail. This was just a summary overview. Thank you for watching, and bye-bye.